Google account. It'll sign you in. This is the Gmail account that I'm using. It takes us straight to any analysis that you've already done. You'll need data sets for this. If you don't have data sets, you can go to educational resources. You can go to the Google Classroom, to the classwork, go to the Institute of Disease Modeling, and in this GitHub, you can go to the tutorial. And in the tutorial, there's files that explain about the app, about the Python code itself. But there's also, you'll see these two .csvs here. So you can download those. So I'm going to download it. And it's going to be downloaded. And I'm going to then also go and download the, this is the count. So I'm also going to download the metadata. So that is also downloaded. And then we are going to move those to a folder where I want to find them. And you'll also want to look at this parameters file so that you know the parameters that you're going to put in. So 0.2, 0.2, 42 for the UMAT-C, 0.75, and 0.043 for cut height. And then admix cutoff, you could do null or very large number if you wanted to output divergence, which isn't such a useful metric for RICE, but we'll see that here when we do it. So I'll go back to the analysis app, and I'm going to do create new analysis, and I'm going to upload my counts file. So I'm going to upload that here. So counts file upload, and I'm going to upload the metadata. And then here I like to put in some information. So I do, RICE tutorial, and then I like to see what the epsilon is that I'm using, and then also the cut height that I'm using. And so you'll remember those from here. So 0.75 and 0.043. So 0.75, we'll put the 0 there so it's more obvious, and 0.043, and then we're going to need to change these epsilons here. This was 0.2, 0.2, and 42, and this is, we're going to have to change this here to 0.43, and then the admix cutoff I'm just going to do is 10. And at this point you can pick a bunch of these options here. The most the ones that are used most are already pre-checked for you, but you could pick any sort of number of them. I'm going to hit run analysis here. Well, that's interesting. This is a little bit stuck in the way. That's unfortunate. Run analysis, and you'll see that it's, running the analysis, and it completed. And we can go down here and we can look at different things that are of interest to us in terms of the outputs. And then you sort of want to reflect on those and think about, what they mean. How you're going to use them. If you need to adjust anything, you can do that. And just, here we see that there's a number of variety detections. Some of them are multi-reference matches. Some of them are single reference matches. I think we call them group and single or unique. And then there's also these genetic entities, and you can see one genetic entity in particular. There's a lot of samples that belong to it. So if you were missing a reference for a popular variety, it could turn out that this is what is really on the landscape. But this could also be something else that isn't an improved variety. So, but it does tell you that there is something out there that people are growing that has a genetic profile that is shared amongst many, many samples, and therefore gets this genetic entity designation. I think just to show about post-processing, there's a number of things that you can choose here. So there was a single cluster of interest. Let's go see here. That genetic entity was in cluster 6, so we can go and just take a look at what that looks like. So if we do for a cluster of interest, we can do 6. If we wanted to change cut height, we could, and then we're just going to do a tick type of references. I'm going to run that analysis, and you'll see up here it's running. And then once that has completed, it will append the new information at the bottom. So here you can see there's no references indicated, and that's because this cluster doesn't have any references in it, but it has 2 genetic entities. This is the one that has a lot of members that we saw. And you can see that there's another genetic entity over here that has fewer members, 1, 2, 3, 4, 5. You can also do heat maps, so if you wanted to take a look at specific varieties of interest, and we saw that there was this variety 22 and variety 26 underscore A. Let's go see if we find that. Let's take a look at these, and again, just the inventory will tell us the inventory identifier, so that can be helpful to see how those fall out. So it's running that analysis. Just point out too that it tells you the version that you're using. So as the Python code potentially evolves, there will be different versions. You always want to be recording down what that is. And so this appended to the bottom here, and you can see then the different inventories being indicated there. I think too, maybe that tick type isn't so useful because we can't see the, let's see if we do source and run it again to see the different tick type. Let's see here. This might be a little bit more informative. Also, you maybe saw that these ones jumped back up to the top. They're appended at the bottom, but then they get pushed to the top when you rerun post-processing. So here you've got a more informative tick type. It tells you what variety it is. So you can see here's this variety 22, and there's a number of sources of it, and some of those sources are repeated, so those are technical replicates. And then you have this variety 26 underscore A, and it's source A that is in with this variety 22. We could then go and look at if we wanted to variety 22 and run analysis. And so you can see you can sort of like iteratively add in other analyses that you want, and in some cases you can also adjust the parameters that you're using if you want to check out a little bit different look. So okay, that is completed. So here you can see the variety 22, and you can see that you've got your different sources here, and you don't have source A, do you? Source B, C, D. So these are the other sources of variety 22 that you can then look at when you're just looking at variety 22, not the variety 22 underscore B. If you wanted to, you could do, oh sorry, that was variety 22. I wanted variety 26. So if we want to do variety 26, we want to do variety 26A and B to capture them. Let's run that. and they'll produce for the variety that has two different things. And what you can see here is that even though these were both labeled as variety 26, they have very different genetic profiles. The technical replicates are matching each other, but the sources, source A is clearly totally different from source B, and therefore the suffix is added so that you know which one you're detecting in which case. Maybe just to show again in this post-processing, so you can run this and accumulate as many of these want. You can collapse them down so that they're not taking up space, and just sort of look through the different visualizations that you've outputted in order to understand the data set that you have and produce information about what varieties or genetic entities are being detected in the samples that you have submitted.